Hi, welcome to this video. In this video, I'm going to show you guys two examples that are about sine rule. Okay, so in this question, they want us to find the missing sides and angles in a triangle ABC. Angle A is 42 degrees. Length of A, segment A, is 33, and length of segment C is 25. So what I have here is I'm just going to make a quick sketch. So maybe something like that. And I'm gonna call this A, that's B, and that's C, and that will be my A. So that's 33, and my C is over here. That's 25, and my angle A is 42. So that's 42 degrees. All right, cool. So we need to find how much is your B, what's your angle B, and what's your angle C. Okay, so that's what we need to do. Okay, I'm gonna leave that question mark there. All right, cool. Then let's go ahead and apply the sine rule. So I have this pair, right? I have that pair over there. So I'm gonna set that up. I'll have sine 42 degrees over 33 is equal to, so I can first find my angle C first, right? I can find my angle C first. So that'll be sine C over 25, okay? And my sine C is equal to 25 times sine 42 over 33. Okay, so my C, I can use my calculator right now. I'm gonna put that in my calculator. My C is gonna be arcsine of that fraction there, right? Okay, so I'm gonna put that in my calculator, and I will have 25 times sine 42. This is 33. Okay, and my C is equal to approximately, so C is equal to 30.45869 blah blah blah. So my C is approximately 30.5 degrees. Okay, so that's how much my angle C over here is, approximately 30.5. Okay. So in the previous video, we know that the supplementary angle would also work, right? The supplementary angle would also be something that we need to consider. So if I find the supplementary angle, I will get 150. Actually, no, 149.5. Right. So the supplementary angle, which is this, would also have the same sine value as 30.5. So we should also consider if that makes sense or not. So let's put it up here, 145.9. So this could be 30 or 149.5. Now, if it's 30, I can find my angle B already. So this will be 180 minus the 42 minus the 30.5, right? And I'll get something from that. What if I use the 149.5? So I will have 180 minus the 42 minus the 149.5. And you will see that you will get something that is negative, because 49 and 149.5, if you add this 149.5 with this 42, if you add them up, that they give you something that's bigger than 180. So which makes no sense, because in a triangle, if you add three angles, the sum of three angles gives you 180. And just by adding these two angles, we have something that's more than 180. So this is not a solution. So the only possible angle C is 30.5. Feel free to rewind the analysis that I just mentioned in the past couple of minutes, okay? Because that is the key. That's the key when we, every time when we're applying the sine rule, we need to consider the supplementary angle, right? And the supplementary angle might work, which is the example that I showed you guys in the previous video. That supplementary angle worked. But in this example, the supplementary does not work, because when I add this with the 42 degrees, which is given to us, we get something that's more than 180. So we don't even have to calculate the value of B with the 149.5 and the 42. Right? So we will only have let me use red. So which means I only have to consider the 30.5, and then 180 minus 42 minus 40.5, 30.5, sorry, I'll get 107.5. But this is this angle here, that is 107.5. And with this, now that I know my angle B, I can find the length of B, right? So I can do that. So let me find some space. So I can set out the equation here. I'm going to write in red. So sine of 107.5 over B is equal to, and I'm going to use whatever is given to us, because so that I have an accurate answer. So I will have sine 42 degrees divided by 33. And if you do that, your B should be approximately 47.0. Okay, so this is approximately 47.0. And that's it. All right. Feel free to rewind. Make sure you understand why this is not an answer. Yeah, make sure you know why. All right, let's look at another one. All right, so here's another one. This is the last example I'm gonna show you. Still on sine rules, and you can go ahead and give it a try. So you can pause the video, give that a try, and come back when you have something, when you have the solution. Okay, so I'm gonna make a sketch. All right, I'm gonna call this A, that's B, that's C. Angle A is 70. The length of A, which is opposite from angle A, is 25. And the segment opposite from B is 28. So they want us to find the length of C and also the angle C. So let's try that. So let's go ahead and use the sine rule. So here I have my pair, right? That's a pair. So I have sine 70 over 25. It's going to be equal to, I'm going to, what can I do here? So let's see if I can use this as a pair. Can I use that as a pair? I don't have anything there, right? So I can't do that. But what I can do is I can use this. I can use the B as a pair, right? It's because B is something that I can find. So let's do that. I'll have sine B over 28. And now let's do some algebra. So I will have 25 sine B is equal to 28 sine 70. Divide 25 on both sides. And I will get this value. So 28 times sine 70 divided by 25. So my sine B is equal to 1.0524 blah 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 blah. Yeah? So if you put this in your calculator, you'll get this 1.0524 something something something. Now, I want you to look at unit circle. And we already talked about this. Sine of an angle, that's the y coordinate, correct? That's the y coordinate on the unit circle. Can you find any y coordinate, any angle with a y coordinate that's bigger than 1? That's impossible, right? It's not possible because my radius is 1. So my highest y value is going to be here, right? Which is going to be 1. In fact, if you try to put this in the calculator, so if let's say today I'm just gonna go with using my calculator, I can find the measure of b by carrying out arc sine. And if you put that in your calculator, you should try to see what happens. It's gonna give you an error. There's no solution. Right? There is no solution. This is not possible. There is no such thing as a sine value that's greater than 1. Okay? So in this case, this triangle. Okay, so in this case, this triangle is not possible. This setup that we have here, is simply not possible. All right, and which is interesting because I thought we can just randomly choose some values and then the triangles, we should be able to put together a triangle with whatever we want. But apparently that's not the case. This triangle does not exist. There's no such triangle where one of your side is 25 and the angle opposite from that side, that 25 side is 70, and another side that's 28 next to the 25 side. This triangle does not exist. And I encourage you guys to think about why. Yeah? But in terms of sine rule, that's it. We have looked at 3 different examples, and I hope you guys understand what do I mean by the ambiguous case, okay? So, hope you find this video helpful. I'll see you in the next one. Bye-bye.